Welcome to the product demonstration of advanced Footstep power generation system using RFID for charging. And in this project we are using HVS-3105 microcontroller to monitor the power coming from this piezo plate, this piezo plate will be generating the power whenever any pressure applied on it, and this will be monitored by this HVS-3105 microcontroller and displayed in this LCD, which is 16:2 LCD. And in here we are using 12 volts 1 amp battery, which is 4 volts 1 amp battery. 3 are connected in series and make one pack. It's a 12 volts 1 amp battery, and it is a rechargeable battery. And to charge this battery we are using two ways. One is from for charging this battery we are using the piezo plate to generate. By generating the piezo energy, we are storing that energy in this battery, and we are using this battery voltage to charge our mobile phone. And this will be in a particular timer, means up to some time only it will be accessed, and that will be accessed by using this RFID and this tag. Whenever we scan this magnetic card by using this RFID reader, then automatically this reading is given to the microcontroller. Then microcontroller will allow us to charge up to 1 minute by giving supply from this battery. And here we are using 12 volts 1 amp battery, but we want only 5 volts DC power to charge our mobile phone. So what we are using here, we are using LM2596, which is voltage regulator, and this will regulate the voltage to 5 volts, from 12 volts to 5 volts, and this voltage is given directly to this USB slot. And from here, this USB slot we can connect to our mobile phone cable, and we can charge our mobile phone. And this relay is used as a switching circuit, and this relay will work will on whenever we scan this card by using this RFID, and then the relay will be on and supply will be allowed to charge our mobile phone. And after 1 minute it will be off to stop taking the charge from the battery. And there we are using another way to charge this battery whenever there is no piezo power, that is transformer. And this transformer, when we given transformer to this circuit, which is charging circuit, then it will act as a rectifier. These 4 diodes will act as like a rectifier circuit, and these 4 diodes will convert the power from AC to DC. Means the transformer is used step down transformer, and when we given 230 volts directly supplied by using this cable, then this transformer will step down the voltage to 12 volts, and this 12 volts 1 amp transformer will give 12 volts AC voltage to this circuit, and this 4 diodes will convert it to a DC, which is pulsating DC, and give it to filter, and this filter will convert it to filter DC, and this DC is given directly to these batteries. But here we are using the piezo, which is DC, generate DC only. So whenever the piezo generated DC, then the circuit will act as a polarity corrector. Means if the voltage is negative also, it will correct and make it as positive voltage and give it to the battery. And by this circuit it will be, and by this circuit when the battery is fully charged, it won't give reverse supply to the transformer or piezo. Why? Because these 2 diodes, here we are using these 2 diodes which are kept in reverse bias from the battery, and it will block the current from the battery and prevent the charging circuit and the kit. And in this microcontroller we having reset button, which is used to reboot our whole system and take the readings, and again when it is hanged. And this is crystal oscillator, which is 20 MHz crystal oscillator used to generate clock pulses. In DC we won't have the frequency, but to transfer the data we want definitely some frequency. So here we are using 20 megahertz frequency, which is generated by this crystal oscillator, and this crystal oscillator will transfer the data by generating the clock pulses. And here we are having two LED indication, one is for power indication and also one is for pulse indication. So the clock pulses are going from the crystal microcontroller will be indicated by this LED, and whenever there is any reading received, then also we will have an indication of this LED to give an intimation that there is a reading given from the input devices or taken by the output devices. And this here we are using capacitor, which is 1000 microfarad capacitor, which will filter the voltage if the voltage having any fluctuations. And the RFID interface to the microcontroller to B0 pin, and this piezo to measure the voltage we are giving the connection to A0 directly, and this LCD interface to B2 to B7 pins. Like this the voltages are interfaced, and this from LM2596 5 volts parallelly given to the microcontroller to run the microcontroller circuit, and from here parallelly supply is given to this LCD and RFID. Let us see the demonstration now. By switching on this switch, which is placed on the battery, we can on the circuit. Footstep power generation, and now we can see there is in LCD it was showing waiting for tag, and this is a tag is used to charge your mobile phone. Now before that I am just giving one mobile phone which is C type. Now it's not charging. Why? Because I have not given any connections or not given any tag. Now unless we show the tag, it will show waiting for the tag, and now I given the tag, it will read the tag and show the voltage, and here we can see the mobile is charging now. Like this we can use the tag after 1 minute, means every minute it will charge up to 1 minute continuously. It will get the mobile will be charged. After 1 minute again we can use this tag, and this type of applications will be used in everywhere to charge your mobile phones up to a limited time. Thank you.